Hello, my name is Bret. This is my show. Every Thursday, I'm here talking Docker and DevOps, and I'm looking for topics today. So if you're new to the show, if you've not been here before, this is something I do every week. I've been doing almost, I think, about 3 years now, actually. There's only been a few weeks where we haven't been able to make it because I was either traveling or vacation or something. And I take your questions, and we talk about it live, sometime with guests. And talking about guests, Nuno, Docker Captain, talking about WSL next week. So we're going to be excited about that show. So glad to have him on and talk about WSL, because I think that on Windows, it's not a matter of if you're using it. It's like, why not? Why aren't you using it? So we're going to get into the depths of containers and other things you can use WSL2 for on Windows. So it will not be a day for Mac people, which I am mostly a Mac person, but I got Windows everywhere. I got Windows on the server in the closet, and got a bunch of Windows machines for testing in my courses. So that'll be fun. I'm sure I'm going to learn something. So join us next week. We'll be talking about that. This week, if we don't have any burning questions in chat, which that's totally up to you, I thought I'd talk about continuous integration, specifically testing. Maybe we'd talk about some of the ways this is going to work in containers, in case you haven't done it yet, or if you're looking to up your game and automation and improving everything. I can draw it out. I've got one of my favorite new apps of 2021, CaliDraw. We will walk through that. It's a pretty neat tool. And of course, for those of you that are patrons, thank you so much for sponsoring this show. This is how this show keeps on living, is if you go over to patreon.com/Bret Fisher. You don't have to buy me a coffee every month, but that is certainly appreciated. For all the open source that I do, including dozens of repos that all recently got updated to support ARM and Apple M1 devices. But you don't have to buy that. You can basically scroll down, click the follow button for free, and you'll get a weekly email just notifying you of what I'm talking about in the live show, what guests I'm having, what open source I'm releasing, what course updates are happening, stuff like that. And we've been pretty quiet lately because we're working on a list of new guests, and I am working on a bunch of course updates that will happen probably in the autumn, probably this fall. So that is something that we're busy on. All right. So before we get to the questions, you've heard me talk about it a lot here. I've been working on GitHub Actions a lot. So Conrad's already in chat saying, "What's up?" And will I be adding GitHub Actions to my courses? So probably. I don't have a timeline for that. I'm also, quite honestly, thinking of just possibly someday an entire GitHub Actions course, because I think that really, like I've been saying all year, I think GitHub Actions is now the new default, right? It's easy. You don't have to run it yourself. It comes with the repos that you're probably already using. So it doesn't necessarily mean that all the testing or Docker image building or everything will be happening there, but people will be using GitHub Actions more and more for various things related to their repos, to automatic ticket closing. Just any automation you're going to do on GitHub is going to be in GitHub Actions, which is why they probably didn't call it GitHub CI, because it does way more than that. But I've been working on that a lot over the last year, in particular the last 4 or 5 months. So it was on my mind today to talk about testing and linting and all the things that you kind of want in your pipeline before your apps get to your servers, and how you can really just do all that on GitHub Actions. Obviously, you can do it in other places, but I think the easiest way to show it off is GitHub Actions. It's certainly, I think, the easiest to use, especially because you start to dig into their marketplace of all their actions out there, and there's just everything. This week specifically, I was working on Ruby testing, and we were using RSpec, one of the Ruby testing tools. And if you look in the marketplace, there's a dozen people with things that support RSpec. We were building out JUnit style test export, so XML files of all the test data. And we were using a pretty nice little marketplace action for taking all of your unit tests, spitting them out in JUnit XML format, and then putting them in this tool that lights up your PR and puts all this great annotation data on your PRs and your commits. And it's just kind of works. Like, you didn't have to do anything to make it all light up. So it's pretty neat how you can plug all this stuff together, and then pretty soon you've taken a repo that just is storing your code, and now it's doing all these things. We've talked about Superlinter here before, which is a great GitHub project that I can talk about again if somebody wants more info on that. But Superlinter is a package that wraps all the popular linters into one action, and you just run it in a workflow. It's only one step in a single workflow job, and it will dynamically look at all of the changes in your code for just that commit or just that PR, and it will lint them. So Markdown, JavaScript, Ruby, Golang, like all the things, right? Docker files, Kubernetes manifests, Terraform files, you name it. It will automatically scan and probably have advice for you, because I'm pretty bad at it too. So every time I use it, I'm like, yeah, honestly, the linting teaches me better coding, better Docker file writing. So I've been a fan of linting for a long time, but it was always a bunch of work to get all the linters and learn them all, like figure out which is the best one for HTML, which is the right ones for CSS, so on and so forth. So Superlinter is a great idea for default, like the thing that you just use out of the box. And then maybe later, if you have opinions and you're thinking, I really prefer this linter over this one, you can customize it. You don't even you don't have to, you can use other linters besides superlinter, but it's a really great shot over the bow of like, linting is a done thing. Like it's just something that you put in all your repos, you put that action on everything you're doing in all your repos. And I'm doing that. So we can look at those today, but on almost every repo now, I've got the superlinter running. So on anything I'm doing, whether it's Markdown, Docker files, whatever, in those repos now, I'm getting linted on my own stuff, and I'm seeing corrections, mistakes that I'm making, or things that I should be doing better, specifically in Markdown, because I thought I knew Markdown, but yeah, not so much. There are some imperfections in my writing. All right, so what do we got in chat? Hello, everyone today. Hello, Bill. Hello, Dan. Absolutely, Dan. I've totally looked at Flux. I've used Flux. Flux v2. I tend to use Argo more now, Argo CD, or at least the projects I see tend to use Argo CD. But I'm not sure because that's necessarily because it's better. They're very comparable. So I'd say try one. If it doesn't do everything you want, then try the other. They have a pretty narrow niche, right? Like they only do really one thing, and they try to do that one thing well. And so if one of those tools doesn't work for you, then check out the other one, and I'm sure one of them will solve your automated deployment problems, at least some of the problems, not all of them. Let's see what else we got. Wendell saying they're going to purchase my courses. Thank you so much. I appreciate you purchasing them. How to pass variables when creating builds. That's almost always through environment variables, but that's highly specific to your CI platform. So if you're talking about GitHub actions, then you're storing that either in the organizational secrets in GitHub or in the repo secrets. So if you're an admin of the repo, you go into the settings, and then you'll see in there you can set up environment variables. They actually have something called environments, so you can actually store different variables for different environments. And then they have secrets. So in the secrets area, that's usually where you're going to store things like API keys, deployment keys, SSH keys, whatever that you need for testing, you'll be storing in there. Steve's got a great question around OPA, Open Policy Agent, and the pod security policy deprecated announcement kind of stuff. I would say, yeah, start with OPA. That's what I see people use the most. And, you start there, and then I don't really have alternatives that off the top of my head. I'm trying to think what they are. But yeah, I would start there. Just between us, Peloton's talking about Sneak, and I've actually seen people at the company talk about that they pronounce it different ways too. So, like most made-up terms on the internet, I'm not sure that there is a correct way to pronounce it, and also based on our own languages, we all tend to mispronounce everything anyway that's not in our native tongue. So he's asking around what repo would be good to look at. So that's a great question. One we can take a look at real quick, only because it's short to type and it's got some of the things, is shpod. So shpod or shpod is a repo that Jerome Petazzoni, a friend of mine, created, and then I forked and enhanced a little bit for my courses. And what it does is it gives you it can launch a pod in a Kubernetes cluster, or you can just run it as a Docker container. And it has tons of tools in it. It has Docker and Compose and Kube Control and Knife and Stern and just like every common cluster management Kubernetes tool out there. So it's called shpod. You can look in the README, and you can actually just one line run it on a Kubernetes cluster, and it will automatically drop you in a shell. Almost all this work is from Jerome, so thank you very much. But there's there's this list of tools out there, K9s, Scaffold, which I really haven't used Scaffold much yet, but and other little utilities like JQ. I think I actually store other ones in there as well that I've updated. So anyway, this is a very simple repo, but it doesn't have a code in it necessarily, right? Other than a shell script, right? So it's got shell script, some other YAML, Docker file. That's really it. So in Actions, you just click on the Actions tab, and we can see the action runs. A lot of these are actually Dependabot, which is great because your actions, like the versions of your software, will get out of date. And Dependabot is now a built-in feature of GitHub that will let you know about new versions and then automatically create you pull requests to update your versions of your actions so that they won't get outdated, right? So you don't have to go and scan for, like there is no, that I'm aware of, there is no action CLI tool like NPM or others where it will go and look and tell you what's outdated, right? So this is the way to do that, is through the Dependabot GitHub Actions. We'll actually look at that in a minute. So if you look in code on any repo and you see that .github directory, that's where they're all going to live under the workflows directory. You see that? And so in here, I'm going to have in a lot of my repos two main actions, and these don't do any CI yet. So I don't have, because this is just course tools, it's not really course code most of the time, I don't have CI going on in here, right? I probably could. I could totally test whether shpod works and do that in here, and that would be a fun project to work on. But the linter is pretty straightforward. This is a single workflow that runs on a single runner, and it's a VM that has the runner agent, and it is pretty simple. It basically checks out your code, and then it runs the linter. Pretty easy, right? And that will look through your application on every commit. Now, the way I design it is on, this is on every commit to my main branch, my default branch, or any pull request to that branch. That's how you do this. So everything in Actions is event-driven, and most CIs are like that. You're not usually manually kicking off CI. Ideally, you don't want to do that. You want it to automate. And the way to do that is to do it based on commits. So the nice thing is it won't test branches that are not my main branch that I'm not, like maybe I just have an experimental branch that I'm not quite PRing yet. I'm not ready to put it into a pull request. Then it wouldn't run this on those commits. All right. Now, the other one where all the action is at is in my Docker build and push. So I try to keep all of my repos up to date, and I will just link this in chat if you'd like to take a look. I try to keep these up to date with my latest way of building a container. So that way you can just check any of my repos and you'll probably see this, assuming it's a repo that builds an image. And you'll see right away that I do some things interesting here that I don't do on the other one. One of them is I schedule, so it will rebuild the image every 15 days. And that keeps my images fresh, including any upstream updates, to the Ubuntu image or the Debian image or whatever I'm using. So that way I keep all the patches from upstream in my images. So even though I might be not changing my code, I want my images to remain fairly patched with upstream stuff in them, right? So I ideally am rebuilding it every 2 weeks. And then here I'm ignoring certain things so I don't want the Docker image built when I just update the README, right? And I also don't want it rebuilt when I'm changing the linter, just because I don't want a brand new image just because I tweaked the linting YAML file or something, right? But once you get down in here, you basically, it's a common theme, and you would do this regardless of what your app is. If it's going to be in an image, these are the common steps. So you're already linting your code. That's like step one. So by the time it gets here, it is going to check out your code. It's going to set up QEMU. We'll see what that's about later. But that's so that you can build multi-platform images for ARM support. So we have to set that up first. Then we will also set up BuildX, because that's the new builder for Docker images, which is great and the only way you should be building images. Then we will enable caching. There's two ways to do this, and currently I'm using GitHub's cache. That way, every time I rebuild the image, any of those layers that haven't changed won't have to be rebuilt. So it makes rebuilding my images later on much, much faster. In fact, I would say most of my Docker image builds, when most of everything is cached, are under 2 minutes. from the time I commit and push to the time my image is done being built and pushed. It's pretty fast. And then we're going to log into wherever we're going to store those images. So I now store all my images on both Docker Hub and GitHub Container Registry. So I use both. Simply that way, you, the user, can decide where you want to get your images. Maybe you're just used to Docker Hub, and that's fine. But I also store them on GitHub in case you, like me, sometimes run into the Docker Hub limits, because there are now pull limits. And if you want to use the GitHub ones out of the box, you can. And then we set the metadata. So the metadata is going to give me labels, and it's going to set my tag. Now, these are pretty simple. So the only thing I'm going to do here is I'm going to hard code it to latest. That's just because I make simple tools, right? These are simple tools for examples and to help you in learning and all that. But you, in your production and your real setup, you should always use tags that you don't reuse. So for example, in mine, I use PR tags and I use commit hashtags. So I will set these up, and you can read all about that. You can just kind of Google the metadata action for Docker, and that will teach you how to set all the tags up there. And those tags I will usually have while I'm testing. It'll usually have the PR number in the tag so that I can pull that latest PR build, and then it will also have like the build ID or the commit ID so that I can get the very specific one for this job, like for that specific commit, if I wanted to download it and reuse it or test it. And then, only then, when everything succeeds, do I then push it with maybe the latest tag, or preferably something that doesn't ever change, like something that's never reused, a tag. So maybe it's the SymVer number, or it's the date-based tag, whatever your typical CI process is going to use. You can do that there. So you set it all up there with custom tags and flavors and stuff. And then you can tag it with multiple ones. So you can have many tags all pointing to the same image. And then this is the meat. This is where all the action happens. And so in my case, I'm actually building it 3 times for 3 different platforms, and it's doing it concurrently. So the build kit builds all 3 in parallel next to each other, and it uses QEMU emulation to do that. And that works pretty well. It's not the fastest, but because the emulation is a little slower. But that's how I would do that. Then I'm telling it, use the BuildX builder that I just made for it. So use that builder. I'm setting up the caching. That way the cache will properly be enabled so that the Docker layers are already there, so I don't have to start from scratch. And then the push is basically an if. So if it's on a pull request that hasn't been committed to the main branch, don't push it to my image registry, right? Because I only want images when the PR is done. When I've actually merged that PR into my main branch, that's when this event will be false. Yeah. So as long as it's not pull request, then push it, is basically what that's saying. And then I add in the tags and the labels, and off we go. And then we do a little temporary fix there. We move the cache. It's a bug, a little bit, a quirk really in the way that Docker works with GitHub images. All right, so let's jump back in the questions there. So that's a simple Docker setup, but that's not really CI. So if we want to talk about CI, we can do that. Let's see. User 1 asks, in your opinion, is it enough to have Argo CD as the CI and CD tool, or is it a combination of Jenkins? So it's called Argo CD for a reason. It doesn't do CI. So yes, you will need something else. Jenkins is fine. Jenkins can be your CI. So what you would do at that point is Jenkins will do all your CI work, and then Argo will do your deployments. And Argo is designed around you doing Git-based deployments. So you will update, whether it's Helm charts or Kubernetes manifest or customized manifest, whatever you're using, you will put those in a repo, and then Argo will pick those up and deploy those to your cluster. So Jenkins is done with testing, right? It doesn't go into it doesn't SSH into your servers and update them, right? That's no longer going to be what you do with Jenkins. You're going to use Argo for that. So you can use Argo or Flux. I do recommend you do that if you're using Kubernetes, that you use those, not your CI tool, because CI tools aren't the best at making sure that your deployment was successful, right? Did your deployment work? How does it know, right? And that's what these other tools will do for CD. They're more intelligent. How to clean an inactive build. Shalish, I don't know what you mean. Could you describe the question a little bit better? I'm not sure what an inactive build is. Is that a Jenkins term? Again, I'm not a huge fan or a user of Jenkins. I tried to leave it years ago for other newer, easier technologies like Circle CI and Drone and GitHub Actions. So my Jenkins is a little rusty, if that's what you're talking about. Can I run GitHub Action workflows locally? If yes, would you recommend it? Yes and yes. I often prefer tools that allow me to run my workflows or my pipelines or whatever you call it. You can run those locally. So with GitHub Actions, there's something called Act. It's not, weirdly, it's not run by GitHub itself. It is an open source project. So, nope, that's not it. Let's see, GitHub Actions Act. So this is a command line utility that you can run your local machine, and it tries to do what the workflows do on your machine. So it uses Docker, and the limitation here is that often it's not going to have access to the secrets that you have stored in GitHub. So if you're using GitHub Actions, you've probably got things in there like Git secrets for accessing your repo and lots of other things. So it won't have access to those. It's not going to go out and reach out. That, at least not that I'm aware of. It maybe has a way to do that, but it can't go out and see those. So often, if it's something fairly advanced in your workflow, you're going to have to come up with a way to make it work and act locally, because if it doesn't have all the things it needs locally, it's going to complain about that. So anyway, it's a great tool. Just called Act. Go check it out. Great question. Do you use K3 for dev machines? If so, any testing differences or significance? I do not. No, I don't use K3. I think I'm assuming you mean K3s. I just use what's in Docker, the Docker Kubernetes built in, because I already got Docker on the machine, and I'm usually running Docker. So if I need Kubernetes, I'll just spin that one up. There's an if you want to use K3s, there is now, let's see. There's a desktop client. It's called Rancher Desktop. Let's see if we can find it. All their pop-ups. So, oh, well. Here we go. Do they have a link? Give me the link. I need the links. I think it's just Rancher/desktop. Let's guess. Let's guess and see if that works. Nope. All right. Let's go to... Let's go to Rancher and... Okay, maybe it's not. Dashboard UI, maybe? No. That's probably not it. Rancher Desktop. Why can't I find this? Here we go. On GitHub. Oh, it's not under the Rancher organization. It's under Rancher Sandbox. Okay, so in case you're interested in using keys as your Kubernetes locally, I don't recommend developing on Kubernetes. I don't see why anyone needs that. I think even with complex setups, I think a compose file is much easier to use and much more lightweight than developing Kubernetes. Now, if you're using apps that specifically take advantage of Kubernetes, then I could see why you might need to have, like if your app talks to the Kubernetes API directly, then yeah, I can see why you would need Kubernetes locally. But I don't normally have Kubernetes running in the background, right? So the main three ways that I run it locally are Docker Desktop by default, because I already got desktop running. I will also use Minikube, but I've kind of stopped using Minikube, and I mostly use microK8s on Ubuntu. So I actually use something called, I'm going to pull this up. This is Multipass. So I use Multipass to create local VMs that are Ubuntu, standard Ubuntu images, and it does it really fast. It does it in like 5 seconds. Super fast, especially if you already have the image downloaded. It'll just reuse that image, and it's really small, and it spins up really fast. So there's no installing of Linux, right? So, but it's a full Linux box. And then inside there, I will use microK8s. But Rancher Desktop is a new thing for keys on your local machine. So go check out Rancher Sandbox. I'm not... and it's like really, really early days, right? But it does let you choose the Kubernetes version, and then it spins up a little small Linux machine on your local machine and installs keys in that. So, and there's probably a GUI. I'll just show you what it looks like. It's pretty sparse. It's pretty utilitarian at this point. It's not super pretty or anything. Yeah, it's not that blog post. I think they had a Docker desktop. Yeah, they just... So it's not... Yeah, so it's kind of like that. Oh, kind of like that. Super basic, but it lets you do similar to what Docker Desktop does. It lets you choose your RAM, CPU, and then places that you want to, like ports that you want to forward, stuff like that you want to have access to inside there. And you can download it here. And there are builds. And it's Mac and Windows. Actually, I'm assuming it also does on Linux, but I don't know. I've never actually tried it on a Linux desktop. So that might be the best way going forward. I've only used it a few times, but I need to try it more. I'm still on version 0.3.0. I'm not sure if that's what their release is. Yeah. So yeah, they haven't done anything since then. But Rancher RKE. Yeah, I mean that is a tool, but I've never used that locally for spinning up my local machines, because I would still need a Linux machine. So you could do Rancher RKE inside of the Multipass Ubuntu machine. You could totally do that. Also having a really hard time explaining why we need tools like HashiCorp Vault to manage secrets and not use only K8s and CI tool secrets. All right, that's a great question, user one. I would, yes, I don't think that everyone needs Vault. And especially if you're using a cloud, the cloud probably already has its own solution so that you don't have to run your own Vault. Because running your own Vault to me is kind of like running your own, it's like running your own CI and running your own image registry. It's like, these are a bunch of plumbing things that there's lots of ways to do it on the internet already, and they're probably better at it than you, and you probably have busier, like more important things to do than run the plumbing and the infrastructure. So I tend to try to avoid running my own Vault, but the reason that you might need Vault is because no one really ever has just one Kubernetes cluster. Eventually you're going to have at least one production cluster, and you'll probably have some staging clusters that stay up, and then you're probably using, eventually you'll have some advanced CI that will automatically spin up things like Kind or other Kubernetes clusters on the fly. So you will end up with a series of clusters. And the problem is now you need to put secrets in all those places. And where do those secrets come from? Is a human putting those in each time manually to each cluster? And if clusters, you kind of want to build your clusters so that they're a little bit, like you want to be able to recreate them, right? I wouldn't call them disposable necessarily unless it's testing, and then you can quickly spin up a Kind cluster and tear it down. But you're going to end up with these clusters, and ideally you can reproduce those clusters or make more at will. But if you store your secrets only in the Kubernetes cluster and you don't use external secrets, then you're going to have work or automation or something for getting those secrets out of somewhere else. Maybe it's Amazon, AWS secrets or something. You're going to have to get secrets out of that and then store them in Kubernetes directly, right? So often there will be tools like Kubernetes external secrets that will allow you to use some other secret store like Vault, like the cloud secrets, and then pull those in your cluster when they're needed, rather than you only using Kubernetes secrets, because that only really works well for manual human intervention when you have like 2 clusters, maybe 3. But after that, when you start to get more and more clusters, it really starts to become a pain to update those via humans. Does that help? You don't have to start that with day one, right? Like you start simple, but as you go and you grow and your environments grow, you may want to look at something like Vault or a cloud secret store. And then you don't have to have it in CI either, right? Because hopefully your CI tool can integrate with that secret store and pull things from it when it needs them, so that you're not storing stuff all over the place, all the same secrets, all the same API keys, right? What is stateful and stateless in Kubernetes? Great question, but I'm going to ask you to ask it a different way. Are you asking what the definitions are, or are you asking specifically about which parts of Kubernetes are stateful? Like when Kubernetes itself, just the system itself, the only thing in it that's really stateful out of the box is the etcd cluster, the etcd cluster. That's basically the database that stores all the information for Kubernetes, including secrets and some of the configuration stuff and all of your YAML. So when you push your YAML to Kubernetes, it stores it in etcd. So that's the stateful part. If you're asking the definition of the two, stateful is information you need to keep. Stateless means that you can throw that container away, or that server or that thing, recreate it, and it doesn't. When you recreate it, it doesn't need that state back, right? So a database is stateful. A web API is hopefully stateless. It may not be stateless, but hopefully it is. It doesn't store state, so it is able to just tear down and spin up as needed without any sort of database or something like that. So I got some votes on CI, more discussions on CI and Argo workflows. Parth asks, is there a way to generate a PAT access token which only is able to access Docker images of a particular repo and can't access my other repo's images? I do not believe so. If you need a PAT is, you can say for a PAT to only access the packages, which includes all packages, not just Docker. And you can give it read-only access, but I don't know that you can do it per repo. So that's where PATs aren't really the right solution. You probably need to look into using a GitHub app, which you can create yourself. So you would make a GitHub app or find one in the marketplace that does what you need, and then have it installed in only the repo, and then use its access to do the thing you need to do. It's kind of hard to talk about because the apps would be different based on what you need, but that I would look at that solution instead of PATs. PATs are kind of a blunt object. They're a tool that basically it uses my credentials and the permissions I give it, but those permissions aren't granular to any organization. Basically, so if it uses my personal PAT, it has access to everything in GitHub that I have access to of that type. So it only filters by type, like repo or comments or packages or something like that, right? So it is very blunt in that it knows the type, but not a scope. Anyway, I don't know if that makes sense. In regards to GitHub Actions, would the CI steps come prior to the build and push, and CD steps would come after the build and push? Thus, do you recommend a separate workflow for both CI and CD? That's great. Let's see. Let's talk about it. So here's a basic workflow. Oh, my head's in the way. So you have a repo, you have your servers, okay? What do you do in between there? Well, you're going to build the image. And so let's do the diamond for steps. So these are basically objects. So resources rather. And so maybe this is your registry. And then assume that everything else in the middle is your CI and CD platforms, right? So step one, if we just drew this out or just listed it, right? So step one is lint, right? Lint on every commit to a PR. So let's assume that you've opened up a PR, because that's usually where a pull request is usually where we kick off automation workflows. If you're toying around in a branch but you haven't created a pull request from it yet, you probably don't want a bunch of stuff there. So I do what is called in GitHub pull request based development. So I will create a PR at the beginning of the development effort to start the conversation around that feature or that fix, right? I like that style because it's out in public. It's out. You're announcing that you're working on something before you have it finished, right? Instead of waiting all the way until you're finished and then saying, okay, feedback on what I did, right? That's, to me, that is a little legacy mindset. Like if you really get hardcore into DevOps, you want feedback continually and early. That's a core principle of DevOps. So thus, I'm going to PR first. So maybe we say create PR. And then I'm going to do large font on this one. So we create PR, do code, and then it commit. And what does that do, right? So the first thing we're probably going to do is hopefully lint. Now, I do lint in parallel. I don't have linting fail my future other work, like building the image, right? I don't have it do that, because typically I will fix linting as I go, but I also want to test the code I just did. And so I'm always going to have linting done in parallel in a separate workflow. So in parallel with linting, I will build an image. So building the Docker image, because if you're doing container-based deployments, if you're using containers to build and ship your apps and run your apps, then everything should be tested in the image. You should not, this is a question from later on, you should not test outside of the image, because the image is your BOM. It's your, your materials, bill of materials that is all your dependencies, the OS that it's essentially running on, the OS tools, and all that's in the container image. So if a lot of times problems with applications aren't necessarily in the code themselves, it's with configuration and dependencies and all that. So I always test in the image. So first, step one is I have to build the image before I can test it. So I build the image, and even just building the image itself, like there might be something broken in the build, right? Because a lot of people will do, maybe if it's a Node.js app, they're doing an npm install, so they're doing that in the image build. So building the image as part of the testing. So we're already now testing, like we're technically testing right now. I would argue that maybe linting isn't testing. We could debate that, but we now are in the testing phase, right? So building the image. And then after that image is successfully built, or in your Docker file, if you want to do unit testing in your Docker file, you could do that in a Docker file. You could technically run your unit test application of choice, right? I used to do it that way, but honestly, with the way that CI tools work, I tend to not do that anymore, because I think I get better feedback and information out of the CI tool rather than the Docker build command, right? So then I'm building the image, then I'm unit testing. Now, these tests, so you're running these inside the image. So technically in a workflow inside of GitHub Actions or something else, now that you have that image, you're going to store it usually on a temporary registry. So in GitHub Actions, I would store that in the GitHub container registry, and I would give it like a PR number, but I would also give it a commit ID number that's essentially a unique value that guarantees it's for this build. So this build right here, this list of things are all going to use that image hash as its tag to guarantee that they're all using the same image. Because I can do these things in parallel, right? I can have a bunch of different things, unit testing, functional testing, whatever testing. I can do all these things in parallel once the image is built, right? So this is all, obviously we were pulling code, right? So we pulled the code, we pulled the code here and right before the linting process. Then we built the image. And once the image is built, I have to store it somewhere. And the reason you have to store it somewhere is because you're going to want to parallelize all of this, which means all these things that are going to run are going to need access to the same image, and they might not be running on the same runner or worker or whatever you want to call the thing that does the job, right? So all those things need access to the image. Thus, you have to store the image somewhere else so they can all get access to it. So you'll need that place, and I like to use the commit hashes because it's easy to identify which commit goes to which image. And maybe those are short-lived images. Maybe you have a feature in your registry, like if Harbor or something, if you're using that, where these images automatically go away after the PR is, merged or something like that. So you're going to need a workflow to clean these up later. But anyway, we do that, and then we're going to pull that image back to do unit testing. Now, in big projects, you might need many unit tests. So you can either do that. In other words, you're going to need to parallelize your testing. All right, I'm working on a project right now where we have 20,000 tests for one repo. So I think it's 20,000. Maybe it's 12,000. I think it's 12,000. 12,000. Basically, it runs tests over and over again on different parts of the app, and so it'll execute 12,000 things. A lot. There's like 700 tests, and they're run over and over in different ways, and it ends up being 12,000. So we have to parallelize that across many servers, and they all are going to pull down the image. And you might have two runners that are running this work, or you might have dozens of these runners running this work. And so you want that unit testing done, and then you're going to do. So unit testing to me means I maybe don't even hopefully need a database, right? But maybe in your app you might need a database spun up or some Redis queue just to do simple unit testing. But ideally, you're doing mock testing so that you don't need that stuff. You can really just do it in code with no extra stuff. And then the next step after unit testing, right, would be we might do functional testing, other types of testing, but this really starts to depend on what you're doing in your app, what that app works with in other places. So in this area, you might be spinning up, right? This might use a Docker Compose file to spin up all the other things it needs in containers, and then to do stuff from the app you're testing and have it talking to all the other parts, right? So you might do a Compose file. If you're using GitHub Actions, you can use something called services, which will spin up individual containers in GitHub Actions. So you don't technically need a Compose file for that. You can just do it in GitHub Actions YAML. So you're going to spin up all the dependencies, and maybe that's other images from other apps you have, other parts of your app, or maybe it's just databases and queues or something like that. And these things, number 6 and 7, can run parallel, right? So they can go at the same time. Now, there's all sorts of other testing. You might have to have things spin up so that humans can manually test. So then spin up testing environments. So maybe you have a process where you need a Kubernetes cluster that is always available with the latest pull request running in it, right? So in here, you might use Terraform and Argo maybe, or Flux. You might use these in there that it runs to dynamically create environments. Maybe you're doing that in the cloud or whatever, so it's going to dynamically create these environments. The environments may not even have existed, and it's spinning those up based on a new PR workflow. So this starts to get pretty advanced, right? This is pretty fancy, but you can totally do that. And maybe the Terraform lives in another Git repo and it pulls that down and it will spin those up. Or maybe that basic testing Terraform is already in the repo with your app. It just kind of doesn't really matter. It just depends on how big your team is and whose job it is to do all this stuff. So this is Argo CD or Flux. So you might just do this with Terraform, and you can maybe skip this part for now, and Terraform essentially spins up that container or that Kubernetes pod or whatever your deployments or whatever manifest you have, it spins them up automatically. It might let that run. It might update an existing cluster. It may not have to spin them up. You might use kind for this. So over here, by the way, this is maybe where you would use kind. Kind is Kubernetes in Docker, and it's a project that you can basically spin up little tiny Kubernetes clusters really, really fast, mostly for the purposes of automated testing. So if you needed to make sure that the pod was to spin up and not crash loop back off kind of thing in Kubernetes, right? You're going to do that here, and you can do it in the cluster, and then basically you would just have some stuff in here that would check, maybe check the health check of the pod and make sure that the pod is healthy. Something super basic. So that way you know the container starts, the app runs as it's supposed to, and that Kubernetes can validate that it's healthy with a basic health check. So that would be, like the easiest way to do that. And you would do that here. Now, 6, 7, and 8, all three of these only have really one dependency, and that is building of the image. So the building of the image runs, it doesn't run in parallel with anything else. You can run these two in parallel, right? Linting and building of the image. And then after the image is successfully pushed, if it succeeds in building, then you could do all three of these. And if all of those pass, right, then step 9 is the final push to prod or push to staging or something. Now, if you're in Kubernetes world, then here is where you would have your Argo, right? So here, you're probably going to have some automation that will either update some other repo that has your Flux or Argo CD YAML, and it's going to go and change, maybe it's going to change the image tag that needs to be deployed. So you've pushed your final prod ready image, right? So since we've done all the testing, we might go back here, and this might be like step 8.5. So everything is green. So step 8.5 is retag image. So we're going to give it a new special tag, maybe like a production sounding tag, right? And hopefully you're not reusing those tags, because that way you can clearly identify, oh, this is a brand new tag that is got maybe it's got like prod at the beginning of it, or some sort of indication that it's prod ready, or it goes in a special repo that's not the testing repo in your image registry. So we're going to then retag and then repush that image, right? And then you can have your workflows down here at the very bottom with Argo and Flux can operate one of two ways. Either they're watching the image registry and they're querying, so they're basically pulling and watching the registry for any special tag using regex, right? So you can say, if I see a new image in this particular repo that starts with prod, then update my deployments on my production Kubernetes clusters with that image. So these tools will watch the registry. The other way to do it, which is the more GitOps approach, is that you have this workflow go and update the Git repo where your YAML is stored for Argo and Flux. Maybe your Helm chart. Maybe you go update the Helm chart. And you're updating the tag that those deployments should use, right? And so that gets updated, and then Argo and Flux will see that commit because they're running in your Kubernetes clusters. And then they're watching Git basically, or it's probably webhook based, right? So they're going to see that, and then they're going to update your manifests in the Kubernetes cluster based on that change. I like that approach rather than the watching for image tags approach. If you're going to watch image tags, you need to make sure that there is a reconciliation at the end that basically updates your repos with that image tag, so that basically you always want to be able to look at Git and know what's running in production. Because we're trying to get towards the GitOps approach, where at the end of the day, if I go to my Flux or my Argo repo and I look at the manifest, I should be able to see a commit that says changed web server image tag to this new tag. And that's what shipped into production, right? And there you go. That's the list. I think that if you were able to get this, you're already going to be in, the top 5 or 10% of organizations, because if you're linting and you're building and automating your image testing, including image testing on Kubernetes using something like Kind, and then you're automatically deploying it. And even if it's not fully automatic, maybe the human has to manually update the final Flux repo because you want to control deployments a little more, right? Maybe you don't fully trust all of your testing, so you need a human to validate it. So maybe that last step at the very beginning, your last step is a human get involved. But eventually, the idea here is that your last human involvement was here. So everything after the human committed code all happens automatically. And maybe it takes hours to do because there's a lot of stuff that has to happen. Ideally, you get it down to where, testing, building all this stuff, pushing to production, that could all potentially happen in under an hour, right? Hopefully you're parallelizing all of this and your testing is spread out so that you can get testing done in under 30 minutes. And then the basic testing, like the unit testing, could get done under 30 minutes. And then maybe you have 30 minutes to spin up the clusters and do all the health checks of the clusters. And there you go. But everyone starts in a different place, right? Everyone starts with basic stuff. So where do you start, right? I would say you start up here. Very first thing you should all be doing is linting. Just set up automation for linting, because you're going to learn a lot just by doing that. I mean, not necessarily the linting itself, right? That's obviously going to check your code, but the process of creating your CI to automate things per commit, that's just a repeatable thing. So once you've learned that, then you learn how to build your image automatically and store it in a registry, right? And then you've learned how to do that now. So you're automating that. And then maybe you're going to start on unit testing. And so you're going to automate that based on the image. Every time the image is built, kick off the workflow to do the unit testing, right? And you just keep going, right? So I wouldn't skip, like what I see sometimes people doing is they skip all of this, right? I'm guilty of this too. I'm guilty of this. They skip all of that and they build the image and then they CD it. So technically there was no CI here, if that's the case. If we deleted all of this and we built the image and then we shipped it with Flux or Argo, then you don't really have CI. You have no testing. You're just building and hoping that it works, right? So yeah, that's what I would do. That's my standard workflow. Hopefully that helps. Could you explain? Oh. I'm reading the chat here. Hello, Victor. Thanks for showing up. Hello, hello. So yeah, if you have any questions about that workflow, I'll leave this up on the screen for a little bit longer. It's a little ugly, I know, but that's what I would do. All right, let's see. Any other questions? Could you explain where a situation, a container will create another container based on the load? So yes, if you're using Kubernetes, it's kind of a built-in feature called the horizontal pod autoscaler, and that will look at metrics coming out of your cluster and simply spin up another replica, basically another copy of your container image based on your requirements. Maybe it's when the CPUs get to a certain whatever, maybe it's the number of connections. Like, it just depends on what metrics you want to collect. And that's different for every app, right? It could be memory usage, it could be CPU usage. I would say start, this very simple one, I would say start with CPU. So maybe if your app has an average CPU over 75% for at least 5 minutes, then spin up another replica. All right, so then you can do that, and look up horizontal pod autoscaler. That's something. And so other tools have that too, right? We've actually had that in AWS for many, many years, known as the autoscaling group. So you could do that with VMs back in the day. You could spin up more VMs and have it auto install things using Cloud Init. And that was what we did before containers. and now that we have containers, you do still need to spin up nodes, extra nodes, and that is different than the pod autoscaler. But you asked about pods, so hopefully that helps. Have I used Customize for configuring YAML files for dev, stage, different environments? Yes. Yes, I have, Dan. Customize and Helm are the two most popular options for deploying Kubernetes work, basically resources on Kubernetes. So, each one has its own pros and cons. I would say that if you're really just building for your team and you're shipping your own software and you're not necessarily shipping it to customers, right? You're just, maybe you're a SaaS or you just use it internally in your company. I might start with Customize and maybe avoid some of the complexity of of Helm. Maybe you can avoid Helm, but Helm is kind of hard to avoid at this point. Like there's so many, if you're going to spin up your own Postgres cluster, you're probably going to use a Helm chart for that. So some people might just say, just go Helm because you're going to use it anyway. So you might as well put everything in Helm. But both of them have their pros and cons. Mixsmack. Thank you for taking my courses, and I'm glad they help. Major question: create a PR first? How? So you're going to create a branch, right? You're gonna create a branch based off a branch, and then just push it. Like don't make any commits. Just push the branch first, and then when you push the branch, make a PR off of that. But there's no changes, right? So that's PR based development, and that's what I really prefer because it gets the discussion started. You could wait until you have your first commit, right? You could maybe do that, or your first 5 commits or something. I typically, if I know it's not something major and it's not going to take a lot of effort and it's just a quick little fix, I may not push the PR and that commit until I have it working locally. So I might just do that because if I'm doing it all in the same day, right? But if it's a long-lived pull request lifecycle, right? If you're expecting to take days or weeks, I will usually just push the PR, get it started, have a good title and all that stuff in there so that I can sort of let the team know. And then you set it in draft, right? So if you're in GitHub, you have that draft button in the PR. So that's your way of saying it's not ready for merging. I'm just getting started. This is a draft, and that helps people have a discussion. If you look in open source, that's what a lot of open source does, especially like in the Docker world. So they'll start the PR that they're working on it, and they might put WIP in the title or use the draft button or both so that people know this is not actually finished yet, so I'm still working on it. But that's what I do. Sadly, you do not see any option here for activating live subtitles. I don't know that that's a thing, but I've never tried. So sorry. Yeah, you have a little different of an approach, testing first, and only if all tests are green, we build the image. And that's fine, Anton. Like, that's better than most. However, if you're not testing in the image, then how do you know your production image is designed to work, right? Now, maybe you have some follow-on testing where you actually ship it into the cluster and you do some testing while it's running in Kubernetes or something. So that's fine too, right? It's the key there is not that you never do testing outside the image. The key there is that once the image is built, you're testing that image before you're putting it on your production servers, right? So you're doing something with it to validate that the app works as expected. Because here's a scenario that I run into, is that there is some dependency that is not in the Docker file. And maybe it's actually a tool that's running on the test server. So you actually have it in test. But when you build the image and ship it, maybe it doesn't have the correct OpenSSL version or something, or it needs some sort of, MD5 tool or something inside there, or a SHA tool inside of your app, and it's not there, or there's some requirement that's not in that image, and the app starts correctly, but then you hit some endpoint in that app. Maybe it's a web app and you hit some URL and then it bombs because it needed something else in the image that's not available. So that's not a common problem if you're using something like Golang or I would say more modern practices where everything is built into the app and you don't have a bunch of external dependencies. But if you look at other apps like PHP or Ruby, maybe some Java, if you look at some of these other apps, the way that they're designed, they have dependencies on the OS package manager, and often I will see problems there. A lot of teams that are new to images, they'll add some new feature to their app, but they don't update the Docker file with a new dependency, and it's on their machine, so it works on their machine, and it's on the testing server, so it works on the testing server. But then when they build the image, the image doesn't have that thing, right? So that's what I see sometimes happen. Hello there, SK. Hello. All right. Thank you. Thanks, Jay. Jaya Kumar. Hopefully I pronounced that correctly. I appreciate you. Thank you. Thanks for showing up. In the case of a monorepo, this is Kodo. In the case of a monorepo that may hold 8 to 12 node microservices, do you use a tool in step 5 that could detect which microservice the PR affected? So yes, well, not necessarily a specific tool. When you say, do you have a tool in step 5 that can detect which microservice? Okay, I see what you're saying. So basically the answer is, how do I know which image to build in a monorepo? And the answer there is your workflows. It's all about your CI tool has to know the diff, right? So if I'm in a monorepo, when I'm doing the build, I will have a different workflow. This is a GitHub specific thing, but most of your CI tools have this. You have paths to ignore and paths to look at, right? To not ignore and to ignore. And so in a monorepo, you would have, if you had 12 microservices, you would have 12 almost identical workflows, right? And so each workflow would kick off for only the paths that you needed for that workflow, okay? So that's how you need your CI tool to know about what files changed in which directories. And then if you're using a monorepo for microservices, you always want to do everything isolated to the directory, right? Because if you end up with, let's say you have a repo, a library that all 12 of your microservices use, and there's some directory that if that directory gets updated, you have to build all 12 and ship all 12. You really don't want to have to do that, right? So ideally, the 12 microservices don't have any interdependencies in terms of building. We call that blast radius. So you want to limit your blast radius of a PR. Ideally, a PR does not force you to have to rebuild every part of your app, test every part of your app for that one PR. Sometimes, in rare cases, you may have to do that, but you really make sure that that's my tip, is make sure that when you're doing the monorepo microservice-based stuff, that you keep things very isolated, so that if it's in the app 1 directory, then it only builds that app, only tests that app, so on. So great questions today, everyone. Thanks for that. I believe that the draft PR is good for work in progress. Yes, absolutely. So I would start a draft PR, then and it may take me weeks to get through that work. And that way people can see all the commits. Like if you were to look at some of my PRs, I might have 100 commits that are eventually going to all squash and merge. Squash and merge, squash and merge. So we're going to get that down to where it's only one commit when I finally merge it into the production branch or the main branch. Any live boot camps I organize? No, I don't have live boot camps. Not for the public. I do have workshops that I do for private companies. So companies will reach out to me and ask me to do a workshop for them. And if you've ever been to any of mine, I used to do them a lot at conferences. You can go to, you can go to container.training. So if you go to container.training, this is actually my friend Jerome's site. And Jerome has he does live trainings mostly over in Europe and French. And you can see our pass list going back all the way, like just so many. And eventually, if you scroll back far enough, you might see them be delivered by other people. So this is going back years and years, right? And a lot of these, the slides are available. Some of them, the videos are available. So that's all at container.training. And I would check that out. All right. Okay, so we've been on for an hour, a little more than an hour. So get your last questions in, your final questions, and then we're going to wrap this up. Could you explain to me the way to change environment on production when the image comes from staging with staging environment? Thanks. So so there has to be an event, right? So your CI, let's say your CI tool that pushes maybe it changes your Argo, your Flux, and it pushes to staging. And then at some point, probably a human, right? A human's going to look at staging and say, yes, we're good to go. And so then you would have a manual workflow. And that means a human has to get involved to kick off the production deployment workflow. So maybe when the staging is certified by whoever you want to do that, because I don't know how you would automate staging to production, right? Like, in other words, once something's on staging, the assumption of staging is that it's there for humans to do something with it. Otherwise, if it's all fully automated, then you're not doing anything on staging other than automated testing, which really isn't staging. So my assumption here for you is that once the staging is authorized, someone goes in, updates a Git repo that stores, maybe it's got your Helm chart, maybe it's got your customize or your Kubernetes manifest. So that's the repo that your Flux or your Argo CD is watching. And so it's watching that repo. You change the image version, like the tag of that image in there, whatever that is, and you change that tag, and then you commit it. And then those tools in your clusters, your production clusters running Argo, it's running Flux, it will pick up that change and then redeploy a new image. It will not redeploy, but it will deploy a new image into whatever you were doing, the stateful set, the deployment, whatever, right? That's how that works. Nobro Gaming, is there any future in Python? Absolutely, yes. Python is definitely one of the top 10, if not one of the top 5 languages every year. So yeah, totally. Use Python if you like it. Anton says, I guess there was a little misunderstanding. I meant some types of testing like unit tests, system tests, in case on README. Yeah. Okay. Yeah, that's what I was hoping. Yeah. So definitely you're doing some testing, saving the image build till after some of that testing, like unit testing. And then you're doing testing after. So yes, I like that. I like that approach. You don't always have to have the image built first, but I tend to just, because I'm the Docker guy, so I'm going to do everything in the images. So that's what my preference is. But yeah, all right. Well, thank you all for your questions. You are so welcome, and thank you for showing up this week. Next week, again, I have a guest, a Docker captain. We're going to be dueling Docker captains with Nuno on the show, and we're going to talk about WSL2. So everything you want to talk about with Windows subsystem for Linux, come check it out next week. We're going to go through whatever you want to talk about. And we might do some demos. Who knows? So we'll have some fun. All right. If you missed, by the way, someone said, if you missed the initial part, yes, this video on YouTube, you just rewind it. Like wait 20 minutes and then the whole video will be available, 20, 30 minutes, something like that for YouTube to catch up. And then you can watch the whole thing over. So, all right. Thanks, everyone. See you next week.